Okay, so this is where I left you guys in the last video, and I told you this is where we write the code for end user to interact with their debugger. And I'll show you how the end user is going to interact with the debugger. So I have a test process and its process ID is 1066. It's going to keep on printing 0, 1, 2, 3 after about 2, 3 seconds. I forgot how long of a sleep I put in there, but its process ID is 1066. And I can stop this process ID with my debugger. So cargo run minus p process ID, and when I run it, it's going to stop that process and give me a command line interface to interact with that process. So it gave me a command line interface, RDV interface, and as soon as we do that, this process will stop. It will not print any more numbers. It will continue printing them if I give it the continue command. So it's kind of like a breakpoint, and as soon as I enter this continue, it will open that breakpoint, and control will start in this process again. So continue, and as you can see, it started printing again. Now I can stop this process again by kind of putting in a hard-coded or like a manual breakpoint by pressing Control C. When I press Control C here, control will come back here again. Now the next thing we want this command line interface to do is to have a history of the command. So if I press the up arrow key, it will show me continue again, because that's what happens in a terminal, right? But that won't happen by its own. We would need to keep track of the history. So I can press C, and that will start this process again. I can stop this process again with Control C, and control will come back here again. Now if I go up once, I see C, and then if I go up again, I will see continue. So this is a history of all the commands. So we need some way to handle this history, and I can break out of this debugger with Control D. So since this process was not launched by our debugger, it will continue on as it was before we attached the debugger to it. So this is a kind of a high level demo of what we want to do in this video. This history that I showed you, we have a crate in Rust that helps us do it. Let me show that to you. It's called RustyLine. We will be using it, and they have this example code right here, and this is all that we need to do that. Actually, we don't need anything else. We just want to do something extra here in case line prints okay. So we will do that. So right now we are not handling all the okay cases, because if you were to go into wait status has a lot of uh, possible variants: exited, signaled, stopped. The one we care about is stopped. So if okay of wait status stopped, and it takes a child PID and a signal, and right here we should print that uh, print line. Let's print that stop signal. अरे यार So print line and signal it is not printable. We need to print it like so, and that's all. But in case our process actually stopped, we now want to be able to debug it. So we'll create this function called debug, and let's pass in the PID to it. We have the PID right here, right? So PID, let's create this function. Uh, PID. And the other thing is, okay, in case of any other status, we'll just print it. Print line, let's just say unexpected status. And let's just process exit with 1. We're not handling any other status code right now. And in case of error, of course, we want to exit out. So now we need to bring in RustyLine. So let's go to our cargo.toml and let's bring in the dependency for RustyLine. Let me copy that. Just paste RustyLine like so. And let's do a cargo build. So the dependency is working fine. We can now start using it in this debug method, debug function. So in this debug function, this is just boilerplate code for RustyLine default editor. I am just looking at the documentation here and just typing that and unwrap. That's the editor for us, and give let error of e equal to rl.load history dot history print line no previous history. Otherwise, after doing something, we'll save stuff to history, and we can save that with rl.save history, and we'll save it to dot history. That will save the history for us, and whenever we bring in the debugger again, it will load that history for us. So right here, what we want to do is we want to run that terminal in a loop. So let read line equal to rl.readline, and it takes a prompt that we need to ask the user rdb. That will be the prompt for us, and we can match the read line. So read line is the result, right? So we can add variants for it, add remaining patterns. So if we get the line, if line not equal to empty, and this read line blocks the current thread of execution, right? So if the line is not empty, let underscore equal to rl dot, we'll add it to the history, add history entry, and we'll add the line dot as star And what we can finally do is write a command handler, handle command, something like that. And so the documentation for RustyLine tells you that there can be different types of error. When we press Control C, uh, it doesn't actually, we don't actually want to break out of the editor. We want to break out of the debugger. So read line error and sorry, L will be small. Read line error interrupted. This will happen when we have a Control C. Control will come here when we press Control C. So let's just print ln. Where's the caret and C. And I don't actually want to break out of the debugger. We only want to break out of it in case of Control D, and the error for Control D is not interrupted but EOF. That's Control D. Control will come here when we press Control D in the debugger. I'll show that to you in a second. Let me write something. Print line, and let's just print line. Argument must be a string literal. Control D, and in case of Control D, let's just print line exiting debugger, Control D, and let's break out of the loop. In case of any other error, let's just print it to ePrint line. And break out of the debugger. I'll show it to you how it works. Let me just cargo run. So we're expecting something, right? This won't work. We need to give it a process ID or something, or a process name. Yeah, give a process binary path ID to attach to. So cargo run sleep. So you see we got a debugger terminal, and I can give it commands. So continue. So it just print continues. Hello. It just prints hello, and we have a history of all the commands. So we need to write a command handler for different types of commands. So right now we are not handling these commands. We need a command handler for it. But if you press Control C, it just prints Control C and continues. But if you press Control D, it exits out of the debugger. That's what we wanted. This is for error for sleep command. We should not use sleep for this. We should use yes. So yes is a process that just prints y for us. Why is it not stopping? It stopped. Yeah. So this is our command line interface that user will interact with. We now want to write a command handler that will parse those commands and handle those commands for us. That command handler needs to interact with the process that we launched or attached to. And we have the process ID. But instead of passing around the process ID, let's just encapsulate the process in a structure. We'll create uh, we'll create constructors for that process that will launch or attach to it, and then set the process ID for it. So right now, in the source in RDB, we don't have anything. Let's add a new Rust file and let's call it process, and let's attach it to, let's make it pub. And in utils also, let's refactor and rename it to attach. So inside of this process, we're going to have a struct, and that struct will encapsulate the process ID in it. Pub struct process, and I will have a, and let's make it data type of PID. All right. Uh, and now we want to impl process, and the first thing I'll create is the pub fn new, and let's not make it pub fn new, and it's going to take a PID and return a self. It's going to return a self, and right now that would be the constructor. And since it's a private PID, let's create a getter for the PID. Fn PID, it's going to return a PID, and let's return self dot head. That will be the getter for the PID. And now I'm going to create two functions, two methods. One is an attach, and this is going to be public, pub fn attach, and pub fn of launch. And we have that convoluted logic right here. So right here we are attaching, we're just attaching. So, and it returns so instead let's return a process, and let's take it to attach, and it needs a PID. So let's say PID arg, and it's a string. Let's make it str, and let's say PID arg, and it returns a result of, let's say it returns a result of a process comma error string. I think now question mark will work. Yeah, and instead of PID, let's say let process is equals to process of new, and let's pass in the PID, and the PID needs to be PID from raw, and let's give it the PID. And now we can return process. So we called attach, and attach is going to return this. So right here I can simply it doesn't take, so I can call it with process, right? Let's go to attach.rs, and process attach pid arg is arg of 2, and it needs to be okay. So similarly, let's bring this logic down to program path. Let's bring this unsafe block to launch. Process and launch, and it needs a program path. Now this program path is also going to be str, and it's also going to return a result of, so instead of this, let's create a process and return that. And right here I can call process of launch and pass in programming path, and it needs to be stir. Okay, so now this utility method is only checking if we need to attach or launch, and accordingly calling the right function for it. We're not keeping that, we are encapsulating that logic in the process struct in itself. Okay, so now come back to main. This is no longer an I32, it's a process, and let's call it process and match process, and let process equals to this, and instead of this, let's say process dot getter pid getter, and it's already a pid from raw. So make pid public. Yeah, this getter method needs to be public, and instead of passing in the pid, let's just pass in the process itself, and this debug is now going to take a process. Okay, and right here what I need to do is process dot dispatch command, dispatch command, and the command is the line. That's what we want. One thing you should fix is, even though it's an okay, we are treating it as an error, so let's print to ePrint line instead. This is in main. We can remove this print line, you don't need to print it anymore. I was just printing it to show you, and instead of handle command I created this dispatch command with function. It doesn't exist yet, we will create it, and it needs to be public. So let's create this function, create method dispatch command, and I already have an impl block, so let's move it into that. uh, Launch, and it's going to be command dispatch command, error goes away. In this dispatch command, the command might actually take arguments. I haven't shown you an example of that yet. I simply showed you a continue example. Now that continue didn't take any arguments, but it's possible that some commands in our command line interface take arguments after it, and those commands will be split by white spaces. So let args and it's going to be args, and it's going to be a vec of struct. Let it be command dot split white space dot collect, and these are all the split parts of the command. The command is just going to be args of 0. Right, and right now we are only going to handle the continue case. So match command, and instead of this, because actually uh, the debugger interface we are trying to build is quite similar to LLDB or the GDB debugger, and those debuggers don't require you to type the entire command continue. Just C works fine. It interprets C as continue. So the command may actually be a prefix of continue, not necessarily be continue itself. So if continue dot starts with command, in that case we received something like C or cont or conti, something like that. It not necessarily be continue complete. In that case, what we will do is I want to resume the process, but we haven't. Yeah. So in the main, uh, in main function, we are stopping the process with wait pid, and when the process stops, we initiate the debugger, and the debugger takes in a command and it dispatches it to the process. And if the command is continue, I want to restart the process. So I'll create a function for it and I'll call it resume, self.resume, and it will be the responsibility of this function to restart the process. But we don't want to give control back to the debugger immediately. So after a process continues, I don't want the control to go back to the debugger immediately. What I want is I want the control to go to debugger only when we hit another breakpoint, or when the process stops again, or something like that. So I'll create another function to help me do that, and then that will be self dot wait on signal, and the signal may be a breakpoint or stops, process stops again. In those cases, I want the control to go back to uh, the debugger. Otherwise, I don't want to. So let's create these functions. Self.resume unresolved. Let's create now. Why is it importing? Why is it not creating? More action. So let me create it. Pub fn resume, and it need not be public, and it takes self, and what it does is it uses the ptrace syscall to continue the process that was stopped, and the process that was stopped is encapsulated in this process struct. It's encapsulated in self. We have the pid of the process in self, so we can do ptrace continue of the self dot pid, and I hope it's imported from the correct place. Yes, it's imported from sys and not libc. Continue, it also takes a signal, and a signal is of type T, and T is an option. So option of signal, and signal, the possible values, the second parameter, the possible values for this second parameter are these. But right now I don't want to pass in any signal. I just want to pass in none. All right. But this may error out. So if let error e, if it errors out, I just want to print line couldn't con continue. Let's print the error and let's process.exit. Process exit with 1. That will be the resume function. Uh, I told you the purpose of this wait on signal is that I don't want the control to go back to the debugger immediately. See, if we leave this out, after continuing the process, my debugger will wake up. I'll show that to you. I don't want that. That's why I'm creating this wait on signal. And this wait on signal, instead of calling the ptrace.continue, it's going to call the wait pid. Wait pid syscall, which we are using here already. So it's going to wait for it to change state. It's going to wait till the process changes state, and as soon as the process changes state, it's going to return. So, which is exactly what I want. I only want the debugger to continue to come alive again when the state of the process changes, as in it has hit a debug point or it has stopped for some reason. So let wait result equals to wait pid, and it's importing from libc. I don't want that. I want nix sys wait. I don't want this one. Please don't use this one. These are not recommended. These are the C implementations. We want the Rust one. Wait pid, and we're going to wait for self.pid and with no options, no specific options. I don't want to customize the behavior of the wait pid. And let's match on the wait result. Okay, and it doesn't matter what comes here right now. So status, I'll just return an OK of status, and this wait pid is going to return a result of wait status comma string, and in case of error I just want to print it. And print line, let's just say wait pid failed. Let's print the error and let's return error e. It's error, no, not string, err, no, error number. Import. So right now if continue, otherwise unknown command, let's just print print line unknown command, unknown command, and let's print the command. I guess that should be working now. This should be working. We can test it. Let's create a new file and let's call it test process.c. It's a C file and it's a very simple C code. All we are doing is we are looping and just printing a number. That's it. And it will also give us the ID, the process ID. It will also print that. So let's try to build and run this process. WSL. Let me clear this. Let me clear this. Let me create a new WSL. WSL. Here we can do cd tests, and I can compile the test process.c file that we just created with this command gcc -g test.c output test process, and we can start running this test process, and it will give you the a process ID 452, and it will just keep printing looping x value. What we can do right here is cargo run -p, and this should work. So as you can see, my debugger came alive. It printed RDB, and this printing should have stopped. It did. So if I type now C, oh, continue, it continues. But why did C not work? Let's try to stop it. Why is it stopped? Why did it stop? So it's working. It stopped again. No, it's not. Let's try to stop this. Control C. Okay. Control. My debugger came alive again. And control. Yeah, it's working. And my debugger came alive again. So if I were to remove this wait on signal, what will happen is this debugger will come alive immediately. So right now, if I press C, as you can see, my debugger is not taking any commands. That's because we have this wait on signal. It's waiting for the process to change states. It's going to change state when I press Control C. I press Control C, it changes state. And as you can see, my debugger came alive again. That's exactly what I wanted. And we can quit our debugger with Control D. Alright, it quit the debugger and the process continues as it were, because our debugger didn't launch the process. It simply attached to it, and we never stopped this process. Alright, but what if our debugger were to launch a process? Would it stop it? Let's see. Yes, and if I were to press C, it starts printing Y. I press Control C, it stops, my debugger comes alive again. If I were to press C, works fine. And if I were to quit the debugger, uh, the printing has stopped because because this program stopped, but under the hood this Y process would not have stopped. I want to stop this Y process as well, but for that we should handle this. Right now we are not doing anything with the returned value of wait signal. So wait signal returns a result. So let's say R also returns a result of let's say it just returns wait status and no right now, and let's say it doesn't return anything right now. We'll change that most probably later on, or we'll handle the errors. So let's handle the error. Let error e equal to self dot, and if it errors out, I want to print line. We already have printed process exit with 1 for now. We'll most probably change that. The other thing that we want to do is this launch function for us. It uses fork, creates another process. So right now there are two processes, and then it replaces the second process with something we gave it. We gave it a binary path, and it replaces the process with that. So this second process is not being closed anywhere. We want to gracefully close it. I just don't want to kill it immediately. I want to shut it down gracefully and then kill it. So what we will do is I will implement drop for process, and But I don't want to stop the process if we only attach to it because it was an externally running process. I don't want to stop that externally running process if you're just attaching to it. I only want to close it if you're launching a process as well. So what I'll do is I will create two fields in process, and they will help me decide if I need to kill a process. So I will say terminate on end, and let's call it boolean, and let's say process state to tell me if it's running or not. If it's running, I will try to stop it and then kill it, and if it's not running, if it's already stopped, I can start simply kill it. So process state, I will create this enum process state, and let's say the possible values are stopped, running, exited, and terminated. Those are the possible values. And right here, let's say it also takes terminate on end, which is a boolean, and it takes process state, which is process state, and let's give terminate on end and process state. So the constructor is fine, but where are we calling the constructors? Right here, I need to give it two more values. So let process state equal to process state of its attach. So my process must already be running. And let's say I don't want to terminate the process right here in case because we are simply attaching to it. We didn't launch it. So terminate on end false, and let's give it terminate on end and process state. Let's use these here as well. Where is the error? Right here. In case of launch, let's say the process is running and we terminate on end false. I want it to be true. I want to terminate on end. And in case of wait on signal, control comes here, means the process has stopped. So self dot process state equals to process state stopped, but this needs to be a mutable then. And where are we calling it? It's being called here. This also needs to be mutable. And I guess this needs to be mutable too. Where is it? Process. Let mute. Let mud process be, and let's make it mutable as well. Let's go back here and we wait on signal, and when the process has stopped, let me set process dot ha loop debug. Sorry, not here. My bad, guys. Not here. This is our debugger right here. Before we initiate the debugger, let me set process dot process state to be process state of uh, stopped. Let me, why is it not importing? Let's make it public. Let's make it public. Let's go to main. Let's import it. So whenever we are stopping the process, we are setting it to stop, and whenever we are exiting out of here, let's say exited. Otherwise, let's say terminated in case of error. Similarly, let's go to process and wait on signal. Let's say error, it terminated. Self dot process state of terminated. And whenever we are resuming the process, let's say self dot process state equal to process state of running again, because it's now running again. So now we can implement drop for process. And before that, we should also derive some, let me implement members drop, and let's also hash derive copy and clone. And inside of drop, let's say println that we are dropping the process with process ID self dot the hell self dot pid. We are dropping it, and but if let process state of running equal to self dot process state, if it's running, then I'll try to stop it first. And we can do that with the kill syscall and passing it the stop signal. So if let error of a equal to kill, and imported not from libc but from nix sys, and let's give it pid, and the signal we want to give it is sig stop. So sig stop. What's the issue here? Remove redundant arguments. Function takes one argument, giving it two. Huh? I thought kill took two. So we actually imported kill from the wrong place, and it's supposed to be sys signal kill and kill comma signal. Be mindful of that, guys. And signal of sig stop. This is the option that I want to pass it. I want to stop the process right now. Eprint line, if this fails, fail to stop process, and with the error self dot print comma e. Failed, spelling is wrong. Failed, and control will come here only if the process successfully stopped. But before dropping or killing it, I should probably detach my current process from it. So right now there are two processes. We started our program. It's forked into two processes. We replaced one process with the program we wanted to debug, and this our original process is now attached to the process that we were debugging. So we should detach them as well. Ptrace detach, and let's import it from pid signal. It takes into option. I think this is the right one. Let me see. Detach. Oh, we already have ptrace. My bad. Sorry, guys. It takes a self.pid and it takes options, and let's say none for now. All right, and now I can try to kill the process. Sorry, not kill. I want to continue the process after detaching from it. So let's use kill and self dot pid comma option is going to be signal of uh, yeah, sig cont. Oops, is it being used anywhere? I hope not. Sig cont, and after we continue it, I will only stop it. I will only kill it finally if we launched it. And I know that from if self dot terminate on it. See, I wanted to detach it. I wanted to stop it if it was running. I want to detach from it in any case. I want to detach from it if you simply attached to it. And I want to continue the process again. And if self.terminate on end is set to true, I want to kill it finally. So if let error of equal to kill, and let's give it self.hit comma uh, signal of sig kill. I hope that will kill the process for us, but if it doesn't, fail to kill process, let's say with error this, and let's give it the self dot hid and the error, uh, and if there was no error, I want to wait for it to stop finally. So gracefully I want to check that it has changed states, and I want to make sure that it has stopped. Self dot pid comma option none. I just wanted to change states. Else wait pid. Let's try to run this again. Test process 871. 871. So our debugger comes alive. The looping stops. Let's give it a continue command. So it continues. Control C. My debugger comes alive again. Continue. Our debugger comes alive again. And let's check the history. Continue. Process continues. Control C. Debugger comes alive again. And now if I press Control D, it should stop. It should stop, and it should try to drop from it, but it doesn't because we simply attach to it. So what that means is dropping, and then if the process was running, we would have stopped it, we would have detached from it, and then we would have continued it. Kill with continue. So our debugger seems to be working fine when attaching to foreign processes. I can kill the foreign process, Control C, and let's try to run, or let's try to launch a process from a debugger. Let's try to launch, yes, and let's say continue. Let's Control C. Hmm. And let's try to dropping 1133. Uh, but as you can see, this process is right now running. Is it running? So when we receive this uh, process.drop, we want to call this. Okay, we want to drop process. Uh, cargo run, yes. See, right now we didn't interrupt a syscall. I simply pressed Control C. Now, if I were to press Control D, yeah, this was missing. We were missing this drop call from our debugger. So this debug method, if we see a Control D, I need to call the drop because that's when our process will be dropped. So our debugger seems to be working fine for both the cases now. And let's try again with, but it won't kill it. But I'll see some logs from it. Okay, so what logs do I want to see? Do I want to see process drop process uh, if not self dot terminate on end uh, print line not killing, and that's self dot kit, and the process ID is 1609. So let's cargo run 1609. I hope this has talked. It has. So let's say continue. Process continues. Control C. Control C. Debugger comes alive. Not killing 1609 because we simply attached to it. It was a pre-existing process. So we are able to stop processes. We are able to attach to them, uh, and we are able to continue them from our debugger. Now, this is a command line interface debugger. It's not a debugger that you see right here. These buttons under the hood are calling commands like this, commands like continue on the debugger CLI. So, uh, so that's it for this video. I'll see you in the next one.